The concept of coordinate invariance suggests that the fundamental physical characteristics of a vector field, such as its tendency to expand or swirl, remain consistent regardless of the geometric system used to measure them. Whether one views the world through the lens of linear grids, cylinders, or spheres, properties like the source density and rotational movement do not change. For instance, a simple field representing position demonstrates a uniform outward expansion that remains constant across all space. In contrast, a gravitational field shows more complex behavior, acting as a constant sink when located inside a solid mass but changing its nature when passing through a vacuum. Despite these differences in how they expand or contract, both types of fields share a defining characteristic. They are irrotational, meaning they do not possess a circular or swirling motion. This quality identifies them as conservative systems, where the total work performed depends only on the starting and ending points rather than the specific path taken during movement. Ultimately, shifting from a basic map of position to the complex laws of gravity transforms the underlying mathematical framework into one that can govern the relationship between mass density and the curvature of space.